Across the global shores of the Pacific Ocean, a great and terrible violence lurks just barely below our feet, winding across an outline of nearly 40,000 kilometers, stretching from the southern tip of New Zealand through the South Pacific, across Indonesia, Japan, and Russia, before stretching all the way down the American supercontinent. The world's grandest ocean is encircled. Along its shores and in its deepest waters, the Earth roils in upon itself in a crushing, molten-hot carnage that has produced some of the greatest destruction that the world has ever seen. Of every 10 earthquakes that happen across the globe, 9 happen here. Among the most powerful volcanic eruptions of this epoch, nearly all of them left their mark on this very territory. Its name is the Ring of Fire, and it's produced more devastating earthquakes, more incredible volcanic eruptions, and more terrifying tsunamis than anywhere else on planet Earth. And in today's episode of Places, we're going to look closely at the Ring of Fire. We're going to trace its path across the globe, understand why it exists, and explore some of the most destructive territorial events that humanity has ever known. When it comes to the Ring of Fire, we've got to start out today's journey with one quick but very important disclaimer. The Ring of Fire, it's not a ring at all. While we certainly admit that the name Ring of Fire does sound pretty cool, it also conjures an image of a perfect continuous ring, which it isn't. Instead, it can at best be described as a sort of bendy horseshoe, one that's dotted with volcanoes, mountain ranges, deep ocean trenches, and a whole lot of islands, and some of the most active geologic zones in the world. Instead of the Ring of Fire, a truly accurate name might be more along the lines of, say, the Horseshoe of Quakes, Shakes, and Violent Explosive Bakes, but that's a bit long, so, well, Ring of Fire it is, isn't it? But it's when we actually begin zooming in at certain parts across the map that it becomes clearer and clearer that we're examining a phenomenon of truly massive scale. Although their inclusion is somewhat in dispute among geologists, we'll start our tour of the Ring of Fire all the way down in Antarctica's South Shetland Islands. There you'll find volcanoes like Penguin Island, Melville Peak, and the almost perfectly circular and incredibly steep and craggly Bridgman Islands poking out of the Antarctic waves and believed to have last erupted barely 200 years ago. Also among the number is Deception Island, which seems, when sailing into its tranquil harbour, rather safe and cozy. View it from above, though, and you'll quickly recognise it as the caldera of a volcano, and that volcano, as it happens, is very much alive. Multiple scientific stations were destroyed there by eruptions in the 1960s, although it's remained sleepy since then and is turning into a bit of a tourist hotspot. Travelling northward, the Ring of Fire runs basically along the whole length of the nation of Chile, where the ring's Andes Mountains range forms a natural land border with neighbouring Argentina. Chile is a land pockmarked by volcanoes, including at least 90 that are known to have erupted since the start of the current Holocene epoch, or basically the last 11,700 years. This is after the glaciers of the Ice Age retreated from much of the Earth. Chile's coast is characteristic of a highly geologically active area, as will be a hallmark of each global area that we speak about today, featuring countless little islands and practically constant underground tremors. Chile's history of earthquakes includes the single biggest in recorded history, a magnitude 9.4 to 9.6 earthquake that we'll be absolutely talking about a bit later on. 20 volcanic eruptions have happened there in the last 200 years, and one of the country's most active volcanoes, Villarrica, is one of just 5 on the globe to boast an active lava lake. The Lascar stratovolcano has erupted many times in recent centuries, and when it blew in 1993, its ash traveled all the way to Buenos Aires in Argentina, 1,600 kilometers or 1,000 miles away. And speaking of Argentina, while the country is located further from the nearest section of the Ring of Fire, it still has volcanoes and earthquakes of its own. Bolivia, to the north, delineates part of its Chilean border by splitting active volcanoes between the two nations. Bolivia's vast high plateau is lined to the west with a formation called the Cordillera Occidental, a stretch of dormant, extinct, and active volcanoes that separate it from Chile. The ring curves around the contours of Peru, where the 19,000-foot tall, that's nearly 6 kilometers, Sabancaya volcano has been erupting continuously since 2016, and where the Ubinas volcano, Peru's now most active peak, surprised the local population in 2006 when it roared to life after having thought to be basically non-hazardous. Moving northward, we travel up to Ecuador, a small nation that's all but inundated with exceptionally active volcanoes relative to its size. There's the Cotopaxi volcano that has erupted some 50 times in the last 3 centuries, while the Pichincha volcano covered the capital city of Quito with ash just a couple of decades ago. The volcano Reventador has been in a state of continuous eruption since 2008, and a few years prior to that, in 2002, it pushed out an ash plume that stretched 10.5 miles or 17 kilometers into the sky. The Ring of Fire tracks along the westward edge of the American supercontinent all the way through the highly geologically active Central American Isthmus. Panama has logged a long series of earthquakes above a magnitude 6, including several during the 2000s, while in Costa Rica, volcanoes like Turrialba and Poas like to spit very heavy rocks at nearby tourists every couple of years. In Nicaragua, the Concepcion volcano is a popular climbing destination, arising out of the waters of Lake Nicaragua, right beside its sister peak, Madeiras. El Salvador is similarly active, logging 8 major earthquakes since 2010, including one in 2012 that produced a major tsunami. In Guatemala, the Volcán de Fuego, fantastic name for a volcano by the way, is distinguished by its nearly constant activity, giving off puffs of gas and ash every few minutes, even today, interspersed with 8 or more major eruptions since September 2012. Nor is Fuego the only one. Its fellow Guatemalan volcano, Pacaya, has been erupting quite often in recent decades, so much so the locals now ignore evacuation orders from time to time. Also in Guatemala, the Santa Maria volcano logged one of the 20th century's biggest volcanic eruptions in 1902, with the volcanic ash traveling over 4,000 kilometers, that's 2,500 miles, to San Francisco in the US. By the way, that was just 4 years before San Francisco was nearly destroyed by a Ring of Fire event of its own, which we'll, again, absolutely be talking about a little bit later on. Now, Mexico might not have much of a reputation for tectonic cataclysms, but its history tells a rather different story. The Trans-Mexican Volcanic Belt droops across Mexico's central regions like a waistband, including a nearly 18,000-foot or 5,400-meter-tall active stratovolcano with a name slightly beyond our ability to pronounce. Another volcano, El Chichon, which was thought to be extinct until it erupted in 1982, when it wiped out 9 villages and a combined nearly 2,000 inhabitants and created a kilometer-wide acidic lake in its crater. Even further north, the American Southwest is known for its frequent and occasionally major earthquakes, giving the residents of Orange County and the surrounding landscape a vigorous shake from time to time. But that's got nothing on the region just to the north, Cascadia. The Cascade Volcanic Arc is home to some 20 or so major volcanoes, stretching as far south as Northern California and as far north as Vancouver Island. There, the land is prone to producing incredibly powerful quakes, while volcanoes in the area, most famously Mount St. Helens, are prone to major and highly violent eruptions that we'll, again, absolutely be covering later in depth. In Western Canada, dozens of dormant and extinct volcanoes line the landscape, and several of the volcanoes and volcanic fields are believed to have the potential to go active. All the way to the north, Alaska's Aleutian Islands are a volcanic island chain tracing a narrow pathway from the Americas to Eurasia, where magma constantly boils and bubbles just under the surface. Across the Bering Sea lies the Kamchatka Peninsula of Russia, where the Pacific coastline and the inland regions are among the world's most volcanically active zones, bar none. Cresting above the landscape are over 150 volcanoes, over 24 of which are considered active, but none quite so fascinating as the tallest among them all. Klyuchevskaya Sopka. Looming at a height of nearly 5 kilometers or 15,600 feet, this particular volcano is considered to be among the most beautiful in the world. Just as striking is the rate at which it rose from the ground, with most estimates placing it at just 7,000 years old. It's erupted several times in the last few years. Just as gorgeous is Kronotsky volcano, which according to some volcanologists is the most visually stunning on planet Earth. Tsunamis are common in the waters off the Kamchatka Peninsula, known as the, quote, land of fire and ice, by both Russians and visitors. The area also features frequent and often intense earthquakes, as well as plains of steam-venting geysers. From Kamchatka, the next major stop on the Ring of Fire is Japan. And is it ever major? Japan accounts for some 10% of global active volcanoes, frequently logs earthquakes major enough that they're noticeable in everyday life, and has a history speckled with some of the most devastating major earthquakes and tsunamis ever. But so too is its landscape defined by its geologic activity, with Mount Fuji being the most iconic of all Japan's volcanic peaks. The archipelago nation gains new islands with a relative frequency as volcanoes climb and climb beneath the surface of the water before finally breaking into fresh air. To the southwest, the island of Formosa, making up most of modern-day Taiwan, is quite active as well, and most of Taiwan today has been designed and built up with earthquake resistance as a top priority. And speaking of East Asian archipelago nations, we come to the Philippines, where volcanic activity and destructive earthquakes are just simply a fact of life. There, Mount Pinatubo is by far the country's most recognizable feature, largely on account of a 1991 eruption that killed nearly 1,000 people and left over 10,000 homeless. Elsewhere, the Mayan volcano is quite picturesque, even as it erupts near constantly and forces evacuations every couple of years. It also features prominently in local mythology, and several festivals each year are held in its honor. The Taal volcano has been similarly active in recent years, spewing toxic gas down onto the Philippine capital city of Manila. It's been several years since the Philippines didn't have an earthquake that caused fatalities, and the country's infrastructure remains relatively vulnerable to earthquakes that modern construction should be able to withstand. Finally, Indonesia boasts immensely powerful geologic forces of its own. In addition to the ancient Toba supervolcano, Indonesia features several ongoing years-long volcanic eruptions. While most of Indonesia's active volcanoes feature a stop-and-start staccato onslaught of individual eruptions, they're considered ready to blow basically at all times. One, the volcano Decano has been continuously erupting since 1933. Indonesia's volcanoes feature heavily in the lore and mythology of locals on each of Indonesia's many islands, with some at the core of local creation legends. One, the volcano of Semeru, is even said to have been transplanted from India to create the Indonesian main island of Java. The country logged several high-magnitude quakes over the course of most years, including 4 quakes of magnitude 7 or higher during the year 2023 alone. Not too far away, Papua New Guinea has logged several eruptions in the last few years, most prominently from the volcano Uluwun, whose volcanic plume has climbed above 15 kilometers or 49,000 feet on 2 separate occasions since just 2019. From Papua New Guinea, the Ring of Fire traces a path out to sea, moving eastward into the Pacific. It includes the Solomon Islands and the volcanic archipelago nation of Vanuatu. There, 2 volcanoes have been erupting on and off for the last several years, including one called Ambrim, which had a lava lake up until late 2018. The island nations of Fiji, Samoa, and Tonga host their own volcanoes, although those are largely not active and are occasionally stirred around by major earthquakes above magnitude 8. Tonga features one of the world's newest islands, One Home Reef, which has been erupting continually for a bit and is expected to build itself into an at least semi-permanent landmass sometime soon. Another, the Hunga Tonga Hunga Hapai volcano, which is mostly underwater, sent unbelievable amounts of water vapor into the atmosphere in 2022, producing a boom that could be heard 10,000 kilometers or 6,200 miles away in Alaska. And it sent an atmospheric shockwave that could be detected all the way in London. Finally, the ring concludes in New Zealand, where the metropolitan area of the nation's largest city, Auckland, is spread across a volcanic field featuring over 50 dormant volcanoes, which are, by the way, expected to erupt again, albeit just at some point within the next several thousand years. The country's beautiful geography is largely a product of its volcanic geology, and it's logged several prehistoric eruptions of supervolcano size, including the world's most recent supereruption at the country's Taupo volcano. Some of New Zealand's most popular ski slopes are on the edge of an active stratovolcano called Mount Ruapehu, which still has minor eruptions in most years. White Islands, a volcano off the coast beyond Auckland, has been spewing volcanic gases continually for centuries. Earthquakes of devastating magnitude are common there, although the country is generally able to stay prepared and respond adequately. Despite over a dozen earthquakes above magnitude 5.5 since 2020, there have been 0 fatalities on the islands as a result. All in all, the Ring of Fire stretches along almost the entire Pacific Ring, a long and nearly continuous line of volcanoes, ground tremors, and telltale island archipelagos that indicate an ancient history in which those same islands rose up from the sea. The Ring of Fire features some incredible natural beauty, alongside a long legacy of destruction. But all of that, great and terrible as it may be, well, that's just the after effects. The real power of the Ring of Fire comes from what happens not before our eyes, but beneath our feet. It's at this moment on our journey today that we're going to take off our usual geography hat for a moment and put on our geology hat to discuss the mechanism that makes the Ring of Fire work. That is to say, it's time to talk about plate tectonics. Apologies to our flat earthers in the comments, by the way. The world does not work like you think it does. We're terribly sorry. We're just going to discuss the entry level today, but rest assured that there's plenty more information out there for anybody who'd like to learn more. Basically, the world's crust, the outer shell of solid rock that we all live on, isn't a single piece of rock at all. Instead, it's broken into a bunch of separate pieces, not with any gaps on the surface that we can see at least most of the time, but way below the actual ground under our feet. These pieces are called tectonic plates. Tectonic meaning related to the structure of the Earth's crust. These tectonic plates are really large, even the tiny ones are really big, and they move at a pace that we fast-living humans would call mind-numbingly slow. We're talking about 1.5 centimeters or about 0.6 inches every year, which according to the US's National Oceanic and Atmospheric Administration is roughly the same growth rate as human toenails. But even that very, very slow movement is enough to cause major destruction. To put it in perspective, consider the difference between, say, a car crash and a train crash. While a car crash can absolutely be very bad, the car's own mass, its own momentum, and its own inertia, the force that keeps moving objects in motion, are typically the only things driving that car forward into whatever it's running into. Compare that to, say, a 50-car freight train. If the lead engine hits something, not only is it hitting with more mass than a car, but it's also got to deal with all of the combined momentum and inertia of the other 49 rail cars behind it. Now, scale up again from a train car to an entire continent-sized tectonic plate, and when that plate moves up against resistance, even at exceptionally slow speeds, the amount of force involved is absolutely enormous. And just like a pair of American football players mashing their helmets together as they both try to grind forward, when one of them gives up, all of that pent-up force is going to come charging in the opposite direction. In the case of tectonic plates, the point where two plates interact is known as a fault line. And there are 3 basic ways that plates can interact. They can move away from each other, they can move towards each other, or they can move past each other. Moving away from each other really isn't the worst thing in the world. This is how things like rift valleys form, as the land literally pulls apart from itself at a rate so slow that there's no real way for human eyes to tell where one plate ends and another begins. Moving toward each other, well, that's a bigger problem. Sometimes this results in a situation where both plates smash against each other, creating features like mountain ranges as the plates' leading edges literally pile up against each other. The rest of the time, this direct collision results in a process called subduction, where one plate gets pushed underneath the other and moves down towards the Earth's molten mantle, while the other gets pushed up a bit and stays basically level. Both kinds of direct collision result in intense earthquakes and volcanic activity, while subduction zones can also produce deep trenches. And finally, there's the so-called strike-slip fault, where two plates are moving past each other. If that sounds less violent to you, well, think again. Because for tectonic plates, this process is less like sliding 2 sheets of paper against each other and more like putting 2 serrated bread knives against each other, blade on blade, and pulling away in opposite directions. There are so many irregularities along the edges of either tectonic plate that they're bound to get snagged up on each other, creating tension and then releasing it very quickly. But even this doesn't tell the full story, because in the case of the Ring of Fire, it's not just one plate that's responsible for the whole region's upheaval. In fact, if the Ring of Fire traced the outline of one single tectonic plate, then there would have to be some very particular factors at play to cause such widespread geological activity all around the Pacific Rim. After all, the plate in question would have to be moving one way or another, meaning that if it was pushing against the American supercontinent, for example, then it would be drifting away from East Asia and Oceania, making destructive events like volcanic eruptions and earthquakes less common in that region, while making them more common in the Americas. Instead, the Pacific Ocean is fractured into several tectonic plates, each pushing and pulling in a range of plates underneath the continents on either side. A total of 5 plates interact with the coasts of the American supercontinent, and although this may get a bit confusing, we're going to run through each of them here. The Antarctic plate near southern Chile and the Nazca plate off most of the South American coast strain against the South American plate, with those plates pushing up against each other directly. The Caribbean plate and the Cocos plate push up against each other under the Central American Isthmus, while the Juan de Fuca plate pushes against the North American plate in the territory that forms the Cascadia region, which, as we mentioned before, is incredibly geologically active, and that's from northern California in the USA to southern British Columbia in Canada. Meanwhile, the Pacific Plate moves sideways against the North American Plate in Southern California and northern Mexico. The Pacific Plate also pushes directly against the part of the North American Plate that, despite its name, hosts Russia's Kamchatka Peninsula and the Aleutian Islands. The North American Plate, the Pacific Plate, and the Filipino Plate all strain against each other off the coast of Japan, while the Filipino Plate, the Pacific Plate, and the Australian Plate all cause chaos in Indonesia and Papua New Guinea. Finally, the Pacific Plate and the Australian Plate wreak even more havoc across Oceania and New Zealand, pushing against each other directly and causing immense destruction in the process. In terms of the actual tectonic processes involved in those areas, the Pacific Rim is made up largely of subduction and collision zones. That is, the places where plates smash up against each other directly. The subduction zones generally feature deep undersea trenches in addition to earthquakes and volcanoes. For example, the Peru-Chile Trench, hitting a maximum depth of 8 kilometers or 26,500 feet below sea level, is formed by the oceanic Nazca Plate subducting beneath the South American continent. The Ryukyu Trench between Taiwan and southern Japan hits a maximum depth of 7.5 kilometers or 24,500 feet because of the oceanic Philippine Plate being subducted underneath the plate that holds most of continental Eurasia. Way out at sea, the Philippine Plate's interactions with the Pacific Plate even produce the Mariana Trench, where the maximum known depth is roughly 11 kilometers under the surface of the ocean or 36,000 feet. Strike-slip fault lines are much less common than subduction or collision zones along the Ring of Fire, but they do happen. For example, the San Andreas Fault runs along most of the coastline of California, where the Pacific Plate and the North American Plate move parallel to each other and often grind against each other's outermost edges. So with that rather large dump of information come two key takeaways. First, the Ring of Fire isn't one tectonic fault line. It's quite a lot of fault lines and shifting plates that just so happen to be pushing outward against the continents on either side of the Pacific. The fact that those plates are arranged in such a way to create a sort of nearly contiguous bendy horseshoe shape, where highly active subduction, collision, and strike-slip faults run almost the entire perimeter, is just kind of a coincidence. And the second takeaway is that it's not a fully connected loop either. It has gaps. It has places where different sorts of fault lines run up against each other, and it's even quiet in some parts, where active subduction zones exist but don't produce many tremors at all. Not only that, but there's also a lot of volcanic activity within the circumference of the Ring of Fire that doesn't actually have anything to do with the ring itself. For example, the volcanic activity of the Hawaiian Islands is pretty much unrelated, and so are most of the powerful volcanoes and earthquakes of Antarctica. And with that more complex reality, we also get to do a bit of myth-busting. The quakes and eruptions that happen around the Ring of Fire aren't typically interconnected. Plenty of major geological events happen around the rough outline of the Pacific Ocean each year, and some of them happen almost at exactly the same time. That, rather fairly, has led to a lot of misconceptions about how, let's say, a major earthquake in Indonesia and a major quake in California could be connected. After all, they happen along that same big, scary Ring of Fire, and earthquakes in one location can set off more minor quakes in locations along the same fault line. But in reality, the fault lines that govern each earthquake are just about as disconnected from each other as they could possibly be, and obviously, it's the same for volcanoes. Now, sure, it's technically possible that seismic activity on one side of the Pacific could trigger seismic activity on the other side, but an event that large would probably require the entire Earth's crust to rip open, which, all things considered, just isn't terribly likely. So, is the so-called Ring of Fire even a real thing? Well, no, not really. It's an effective shorthand to describe a geographic belt around the Pacific where some geologically spicy action tends to occur, but the mechanisms that drive that seismic unrest in one area are pretty much unrelated to all the other areas. But then again, it's still kind of a thing, because although the plate tectonics involved don't create one single contiguous fault line, they do create an extremely active Pacific Rim where you can, in practice, trace a near continuous line of extreme seismic activity. In fact, roughly 90% of all global earthquakes happen along these fault lines, and they're where most of the world's active volcanoes can be found. And while the earthquakes coming from the Ring of Fire fault line won't cause earthquakes in a far-off second fault line, the destruction in one location can still have major repercussions elsewhere. And it's here that we come to the Ring of Fire's other nasty surprise, the tsunami. These are gigantic ocean waves caused when large-scale geological activity in one part of the ocean displaces a massive amount of water that then travels away from the epicenter of the earthquake or volcanic eruption, like ripples traveling outward from the center of a pool. While these ripples are typically quite fast-moving and hardly noticeable when they're out at sea, they become a much bigger problem when they approach land. As the ocean gets shallower and shallower, with the same amount of excess water still rushing toward land, these giant ripples build up into giant waves, sweeping inland with devastating effect. These walls of water can travel far onto dry land, and just like the ripples in the pool that we mentioned, there isn't just one. In a major tsunami event, coastlines will be battered by tsunami wave after tsunami wave, and quite often, the first wave that hits won't even be the biggest. And in the Ring of Fire, that's a huge problem. Taken together, the combined coastlines of all the nations on the Pacific Rim, plus all the coastlines of the island landmasses near the coasts or out on the open ocean, run for hundreds of thousands of miles. When a big enough seismic event takes place anywhere along the Ring of Fire and the conditions are right to cause a tsunami, that means that those hundreds of thousands of miles of coastline are all at risk of being impacted. If Chile logs a seaside earthquake that measures a 9 on the Richter scale, Japan's not going to have an earthquake because of it, but the people of Japan are going to want to move to higher ground, with little way to tell just how massive an incoming tsunami might ultimately be until the moment it arrives. The Ring of Fire may not be real, geologically speaking, but when the seismic activity that happens along nearly the entire outline of the Pacific Ring has its effects spread across an entire shared ocean, well, we'll just put it to you this way. Just because the Ring of Fire is just a literary device doesn't mean it's not a good one. Now, we've spoken about the Ring of Fire in broad terms and delved into its complex subterranean mechanics. But what we haven't done, at least not yet, is to explore what it means to live along these unstable and often violent stretches of the Pacific Rim. But for better or worse, people have had a front row seat to the Ring of Fire for the better part of human history, and many of the largest and worst seismic events of the region have been extensively documented. And when it comes to a tour of the real-life historical dark side of the Ring of Fire, we're best off starting big, with the most powerful volcanic eruption ever to take place in recorded history. The volcano in question? Mount Tambora, today part of Indonesia, but in the year 1815 claimed as part of the Dutch East Indies. At the time of its eruption, Tambora had been dormant for centuries, but after a few years of gas emissions and minor tremors, it blew all at once. The sound was so loud, it was recorded on islands over 1,000 kilometers away. Ash would fall as far away as Borneo, and as many as 150 cubic kilometers of ash, pumice, and toxic fumes, 36 cubic miles, were expelled into the air over the course of a several-day eruption. About 10,000 people would die directly because of the volcanic eruption, alongside tens of thousands of others who would die of disease and starvation because of the havoc wrought across the region. Mount Tambora would lose over 1,400 meters of its elevation, a full third of its pre-eruption height, and in exchange, it would gain a gargantuan crater. Fine ash particles floating through the atmosphere led to brilliant sunsets as far away as London. These were put into the stratosphere by a column of ash that may have risen as high as 45 kilometers or 148,000 feet above the surface of the Earth. But Mount Tambora's most severe effect was its role in creating the year without summer. Mount Tambora set off a global cooling effect, causing famines across Europe and Asia, sending temperatures into a dip around the world and creating consecutive deep freeze winters in the United States. Tambora's after effects would kick off a wave of American westward migration across the Ohio River, lead to a typhus outbreak across the British Isles, and even create the conditions in which Mary Shelley wrote the novel Frankenstein during a miserably cold summer. But although Tambora would be the greatest global eruption in recorded history, it wouldn't gain nearly the reputation of eruption nearly 7 decades later, an order of magnitude smaller, but one that took place just as word of its destructive power could be spread rapidly by telegram lines across the globe. The volcano to go off this time would be Krakatau, also of modern-day Indonesia and the historical Dutch East Indies. Krakatau had been fuming for months before its grand explosion, but on August 26, 1883, it roared to life with devastating effect. Over the course of its long eruption, it would produce the loudest sound ever recorded in modern history, heard in Australia and even on the island of Mauritius, some 4,500 kilometers or 2,800 miles away. A pressure wave from the blast would travel around the globe 3 full times before it dissipated, and the ash plume from the eruption would rise 80 kilometers or 50 miles into the sky. On the ground, Krakatau let loose a gargantuan pyroclastic flow, a washing mix of blocks of hot lava, volcanic ash, red-hot pumice rock, and toxic fumes charging across the ground at speeds of about 80 kilometers an hour, 50 miles an hour. The flows burned incredibly hot inside, consuming parts of the nearby islands of Java and Sumatra. The tsunamis from Krakatau were even worse. The Indonesian province of Banten would log a wave of over 40 meters, that's 130 feet high, and the tsunamis caused by Krakatau would kill some 34,000 people in total, nearly all of the deaths attributable to the eruption. In the years since, the Krakatoa crater has seen a new volcano come grow up from the ground called Anak Krakatoa, or Child of Krakatoa. In 2018, Anak Krakatoa would produce one of the 21st century's most devastating volcanic eruptions, producing tsunami waves over 80 meters, 260 feet high on nearby islands, although far less people were killed than had been in 1883. The lessons learned by the scientific community in the wake of Krakatoa would pave the way for the modern study of volcanology. Moving across the Pacific Ocean from Indonesia, we find ourselves in San Francisco, California, on the American West Coast in the year 1906. In April of that year, entirely without warning, the California coast slip-strike fault line ruptured in a magnitude 7.9 quake, centered almost exactly in the city of San Francisco. While the quake wasn't accompanied by a tsunami, the quake itself did more than enough. Over 3,000 people died in the quake, and more than 80% of the city was reduced to rubble, leaving well over half of the population homeless. The fires sweeping across the city were even worse, leveling most of what the earthquake itself had left behind. Some of those fires had been caused by firefighters improperly using dynamite to create gaps in the flammable material on the ground. Another fire, which famously consumed City Hall, was started by a local resident trying to make ham and eggs for breakfast. Prior to the quake, San Francisco had been on track to become the US West Coast's most dominant major metropolis, but with San Francisco set back many years by what had happened, that population, industry, and trading potential migrated to Los Angeles. In the scientific community, the massive ruptures observed across nearly 300 miles, 475 kilometers of the San Andreas Fault would force scientists to rethink what they thought they knew about how earthquakes happened and form the theories that still guide modern thinking to this day. And then we come to Japan in the year 1923, when the Great Kanto earthquake, magnitude 7.9, devastated Japan's central Kanto plain, where the modern city of Tokyo stands today. The earthquake and the resulting fire would kill well over 140,000 people, a substantial portion of whom went missing and could just never be found. Firestorms swept across Tokyo for 2 days, and 38,000 people who'd attempted to take shelter at a single downtown location near the Sumida River were killed by a single massive fire whirl. The incident was made worse by the winds of a nearby typhoon and a resulting tsunami, with 10-meter, 33-foot waves devastating the nearby Izu Islands. Making this apocalyptic situation somehow even worse, rumors spread in the aftermath of the quake that ethnic Koreans were taking advantage of the disaster to loot and burn Tokyo. The true number of Koreans killed, or people mistaken to be Koreans, is unknown, but it's estimated to have run into the thousands, with most killed by angry mobs. The process of reconstruction after the quake and the massive task of rebuilding Tokyo would send Japan directly into its imperial rise, kicking off a cycle of expansion of Japanese society that would only truly end when a pair of atomic bombs fell on Hiroshima and Nagasaki. From Japan, it's on to the big one, the most powerful earthquake ever recorded across all of human history. The quake in question went down in 1960, with an epicenter near the town of Lumaco in Chile, south of the Chilean capital of Santiago. The earthquake hit a magnitude of roughly 9.5, an incredibly powerful tremor that was preceded by several foreshocks above magnitude 7. On the 22nd of May 1960, the Valdivia earthquake hit, so named for the port city of Valdivia, where nearly half the city's homes were leveled and hundreds of people were killed. A powerful tsunami spread outward across the Pacific Ocean, killing dozens of people in Hilo, Hawaii, over 100 more in Japan, and impacting as far north as the Aleutian Islands and as far westward as Indonesia and Vietnam. While the earthquake was devastating for the region of Chile where it happened, the quake's location was also a stroke of luck. If a major earthquake was going to happen anywhere along the Pacific Rim in 1960, better that it happens in southern Chile, where infrastructure was limited and the number of lives destroyed was in the tens of thousands. Transpose an earthquake of that size onto Tokyo, onto Los Angeles, onto Manila, or Seattle, or Quito, and the death toll could have been far, far worse. The fault lines around Valdivia let loose another devastating earthquake in 2010, a magnitude 8.8, killing another 525 people and tying two historical earthquakes as the sixth strongest ever recorded. Just a few years later, an earthquake of almost the same intensity would cause chaos on almost the opposite tip of the American supercontinent. On March 27, 1964, south-central Alaska near Anchorage sustained a magnitude 9.2 earthquake, the most powerful ever in recorded North American history. According to seismic analysis, the earthquake released 500 years of built-up tectonic strain, causing the ground itself to move up to 60 feet along a continuous fault of 600 miles or nearly 1,000 kilometers. The quake would cause a sea tsunami of up to 220 feet or 67 meters in an inlet called Shoup Bay, with the tsunami rippling all the way down to California and Hawaii. Landslides into inland bodies of water, like lakes and rivers, would cause their own tsunamis, devastating the landscape nearby. A total of 131 people would die as a result of the quake, most of them in Alaska, although several died in Oregon and California due to the waves. During the quake and the subsequent devastation, one broadcast journalist, Jeannie Chance, would perform a continuous broadcast of over 24 hours, trying to keep the public informed, coordinate a response, reunite families, and more, while the remote Alaskan city waited desperately for relief. In Guatemala, the general public wasn't nearly so lucky when in 1976, the small Central American country was struck by its own catastrophe. At just a depth of 5 kilometers, or 3.1 miles below the surface of the Earth, along a continuous rupturing fault line of 240 kilometers, or 150 miles, Guatemala was rocked in February of that year by a magnitude 7.5 quake. Although it was of significantly lower magnitude than either the Alaskan or the Chilean quakes of the previous decade, the death toll was far higher, in a clear example of just how destructive such earthquakes can be when they hit densely populated, unprepared areas. Although most homes in Guatemala at this time were built low to the ground, they were also made of adobe, a material that caused them to collapse very quickly once the quake began. In addition, it struck in the early hours of the morning, when most people were in their beds. Over 23,000 people would be killed, alongside 76,000 more injured, with most of the deceased already gone by the time the sun rose that morning. Over 1.2 million were left homeless by the quake. 4 years later, it was the continental United States' turn to be visited again by the geological gods in a 1980 volcanic eruption that we'd guess a fair proportion of our viewers have identified before we even said its name: Mount St. Helens. Not only was it a major Ring of Fire volcano incident, but it was the first volcanic eruption in the lower 48 US states since a quite minor eruption in 1915. For 2 months prior to when Mount St. Helens blew, the volcano rattled and vented hot steam as its slopes twisted and fractured to deal with the magma below the surface. On Sunday, May 18th, 1980, the entire thing blew. First, the mountain's entire north face basically slid off in the largest subaerial landslide in recorded history. Then a mix of lava, gas, and rock exploded forth from the side of the mountain, launching ash 24 kilometers, 15 miles into the air, from which point it would eventually fall in 11 US states and across much of Canada. Mudslides caused by melting glaciers on the volcano face rushed for 50 miles into the Columbia River. 57 people died in the blast and the aftermath, although luckily over 300 loggers who might have been working on and around the mountain ended up not being present on the day of the eruption. And if the eruption of Mount St. Helens in 1980 was bad, then the 1991 eruption of Mount Pinatubo in the Philippines was far worse. Although Pinatubo's eruption lasted for months in total, the peak of that eruption came over a few days in mid-June, with several successive ash columns launched into the atmosphere during the worst of it. The highest of those ash clouds would rise 40 kilometers, 25 miles into the sky. Although it's impossible to say for sure, the eruption of Mount Pinatubo may have been triggered by a 7.7 magnitude earthquake a year earlier, after which time steam started venting from the volcano and earthquakes became more and more frequent. During the peak days of the eruption, Mount Pinatubo itself collapsed into a caldera, much like Mount St. Helens had done, and pyroclastic surges traveled for up to 10 miles, 16 kilometers, before layering the landscape in ash and pumice. At least 16 commercial aircraft would be damaged by the ash cloud while in flight, and in all, the eruption released thermal energy, the equivalent to 70 megatons of TNT, significantly more than Mount St. Helens. It was the second worst volcanic eruption of the 20th century, surpassed only by the eruption of Nova Rupta, a remote Alaskan volcano, which luckily didn't claim any lives when it erupted in 1912. The victims of Mount Pinatubo weren't so lucky. 874 people were killed, mostly by roof collapses, though the death toll almost certainly would have been higher if not for an innovative and far-reaching eruption preparedness campaign in the preceding few months. The portion of the Ring of Fire that stretches through East Asia had yet more tragedies to dole out over the coming decades. 2004 was a year of incredible tragedy, even compared to the Ring of Fire's usual, almost entirely because of an earthquake that took place on the 26th of September of that year, just off the coast of the Indonesian island of Sumatra. This earthquake was incredibly powerful, measuring somewhere between magnitude 9.1 and 9.3. Not only was it among the very largest ever recorded, but it was found to have caused the entirety of planet Earth to vibrate back and forth as much as a centimeter, and it even changed the Earth's rotation. In the 2004 earthquake, a full 1,000 miles or 1,600 kilometers of fault line slipped a distance of 15 meters or 50 feet in an absolutely massive rupture that caused the seafloor itself to rise by several meters. And with that change in the seafloor came water displacement on a scale humans have only very rarely had to experience. The resulting tsunami would reach as far as Chile to the south and the Arctic Circle to the north. But the real devastation would come all across the Indian Ocean, where the worst of the wave had spread. In Indonesia, 167,000 people or more were estimated to have died, swept away by tsunamis that reached as high as 30 meters or 98 feet tall in some places. Sri Lanka, Thailand, and India also saw coastal areas devastated, and the Maldives were, for a while, assessed to be in danger of being swallowed completely by the sea, although luckily that didn't happen. Even Somalia, 5,000 kilometers away from the epicenter of the quake, reported hundreds of fatalities. In all, the quake and the resulting tsunami are believed to have killed nearly 228,000 people, displacing nearly 2 million more. And finally, there's the quake that ravaged Japan in the year 2011, the Tohoku earthquake and the resulting tsunami. Even if many of our viewers might not be old enough to remember the other earthquakes that we've discussed today as they happened, we'd imagine that most are old enough to remember this one. It was a magnitude 9.1 earthquake, the strongest ever recorded in Japan's history, and the fourth largest recorded of all time. It shifted entire portions of Japan's landmass multiple meters towards the Americas, caused a shift of the Earth's axis by between 10 and 25 centimeters, sped up the Earth's rotation, and caused a tsunami that would crest in some areas an estimated 40 meters high or more. Nearly 20,000 people would die in the quake, thousands more would go missing, and hundreds of thousands would remain displaced several years later. If all of that wasn't bad enough, the tsunami would crash over seawalls and cause explosions at a nuclear power plant, Fukushima Daiichi, prompting a nuclear meltdown at the plant that spiked radiation levels inside the facility to 1,000 times the average. Radioactive material would spill out into the ocean, would later be found in tap water, and would be found in contaminated soil across the Fukushima prefecture. While the incident wasn't quite as bad as Chernobyl in the 1980s, it was the worst nuclear accident of the 21st century thus far. The cleanup between the earthquake, the tsunami, and the nuclear meltdown would take several years, and the Fukushima plant's radioactive water only started to be disposed of in 2021, a full decade after the quake occurred. With so much undeniable potential for destruction, it's only natural to get to this point in an episode like this and ask, what's next for the Ring of Fire? Certainly, while we here on Places don't have these sort of omniscient powers that would allow us to predict seismic events, we can state with reasonable certainty that the Ring of Fire is not done with its devastation. This is a region exactly as it's been. Awash in fault lines, subduction zones, colliding tectonic plates, active volcanoes, and a whole lot of water to create some truly massive waves. The tectonic activity at play within the Ring of Fire will not slow down for a very, very long time, and until it does, these sorts of events are bound to keep occurring. But there's also another side to that same coin, that while these disasters are bound to happen, it's not clear which parts of the Pacific Rim that they'll tear apart next. And to be clear, the Ring of Fire is not always producing mega disasters like it's done in its worst moments. In 2023, the year that saw many tens of thousands die in an earthquake in Turkey and thousands of others killed in quakes in Morocco and Afghanistan, the most deadly Ring of Fire earthquake happened in the Ecuadorian coastal province of Guayas. Death toll? 11. Although it logged well over a dozen earthquakes at magnitude 7 or above, very few of those earthquakes caused death or major damage. But because we here at Places know how popular science writing works, we're going to ask the question before you all do it in the comments. Is the Ring of Fire overdue for something major? Well, no. And moreover, that's not how anything works. While a given part of the world can track its historical earthquake record, or a given volcano can have its past eruptions written down chronologically, and while scientists and laypersons around the world can take rough averages and say things like, Los Angeles is way overdue for the big one, the reality is very different. Earthquakes and volcanic eruptions don't follow a schedule, and the subterranean points at which snagging tectonic plates result in a massive release of tension are entirely unpredictable using our current technology. Humans can calculate how likely an earthquake is to happen in a certain place in, let's say, a given year. But even if those estimates are relatively decent, they're just a matter of taking averages from the past data in ways that tell us nothing about what's actually happening beneath our feet. Now, whether you take comfort in that reality or find reasons to be fearful is up to you, but rest assured that any news article or social media headline you see saying that a certain place is overdue, and yes, we do mean every headline, it's BS, allegedly. As far as what the 2020s will look like across the Ring of Fire, you guessed it, we can't predict a thing. The most devastating Ring of Fire event in this decade so far came on New Year's Day 2024 on Japan's Noto Peninsula. There, a magnitude 7.5 earthquake ripped across the landscape, killing 241 people in total and displacing well over 10,000. The resulting tsunami was, luckily, quite minor in most places, damaging seawalls, destroying a few homes, and killing at least one person, but largely avoiding the sort of carnage that prior Ring of Fire tsunamis have caused. But what we don't know is whether this relative lack of destructive potential will be remembered as part of a generally quieter decade across the Pacific Rim, or simply a footnote in advance of a record-breaking earthquake that could happen tomorrow. And regardless of when they happen, the massive earthquakes, the catastrophic volcanic eruptions, the terrifying tsunamis, they all will happen, sooner or later. Indonesia, Alaska, Chile, Japan, all these places are going to continue to have major seismic events. Los Angeles will get the next big one someday. The only question is whether any of us will still be alive to see it, or whether it'll be our grandchildren or their grandchildren who do. Major tsunamis will cross the Pacific time and again, but trying to predict where they come from or where they will hit hardest will be roughly as successful as trying to predict which exact day out of the next century will be the rainiest. When quakes and eruptions do happen, they'll continue to occasionally smash through records that have already been set. After all, the scales we use to measure earthquakes might have only picked up at 9.5 at worst, but they don't stop at 10. A whole lot of crazy tectonic action is possible that recorded history simply hasn't included yet. Unless you think that no volcanic eruptions across the Pacific Rim could potentially be greater than that, say, of Mount Tambora in 1815, well, think again. The United States, Mexico, Chile, Japan, Russia, Indonesia, and New Zealand all have known supervolcanoes around the Ring of Fire that modern humans have not yet seen erupt, and many of them will erupt again. Trying to predict when that will happen using current technology and our current understanding of seismology is simply not worth the effort. One thing we can predict with at least some confidence, though, is the faraway future of the Ring of Fire, and specifically how it, like all things on Earth, will eventually end. As we mentioned previously, the Ring of Fire seismic activities are brought on by a whole range of multi-directional tectonic forces, but if there's one broader trend among those forces that's generally a decent indicator of the big picture, it's that the Eurasian supercontinent and the American supercontinent are on a collision course. Now, we've got to specify this is a very, very slow collision course. Again, we're talking about movement that happens roughly as fast as your toenails grow. And we've got to specify that this is just one theory, even if all the trend line seems to point in that direction. But if the theory is correct, it'll lead to the formation of a new supercontinent, one that's got its name from a geologist named Christopher Scotese in the 1980s. That name? Pangaea Proxima. And it's hard to say anything really about Pangaea Proxima with any level of confidence, but by this time, the world will look very different than what it looks like now. Parts of some continents will have folded onto other parts of the same continent or gotten joined with other continents in places currently unexpected. New mountain ranges will spring up to incredible heights. Siberia will move toward the equator. Alaska will collide with Mexico's Baja California. Antarctica will break in two, and the Mediterranean will just cease to exist. But the most important takeaway for the future of the Ring of Fire itself is that the process of closing the Pacific Ocean and joining America to Eurasia won't actually happen. Instead, the trajectories of those continents are expected to switch around over 100 million years from now, with the Atlantic eventually being swallowed up and the Pacific thus widening to become a new global ocean. And because people who study this sort of thing are way ahead of the rest of us, that ocean already has a name, the Neopanthalacen, which, according to geologists in the know, will take up much of the Earth's surface. So while the tectonic plates that make up today's Ring of Fire will most likely have disappeared long before that future ultimately comes to pass, the shores of the Pacific Rim may well become the shores of a new global supercontinent. Not that any of us are going to be around to find out. And if that's all a bit heavy for the end of today's episode, well, fair enough. But if there's one key takeaway in all of this, is that the Ring of Fire, even though it may not be quite the cohesive superstructure it's made out to be, is still very much a real thing in the lives of the hundreds of millions of people who live all around the Pacific Rim. It is a land of fire and fury, a land of incredible tectonic power, and at times, incredible devastation to go with it. It's when we look at phenomena like the Ring of Fire that we realize how tiny humans are, beholden to the power of a planet that goes far beyond anything our tiny little mammal brains can possibly comprehend.